the last Guinness Book of World Record made by Davis computer, which calculated 62.8 trillion digits of pi. The ratio of a circumference to its diameter is a mystery from ancient Babylonian ages. This is a picture of a Babylonian tablet which shows that not only today's mathematicians but the people who initiated the hunt for pi were the Babylonians and Egyptians 4000 years ago. As Indus Valley script is not deciphered yet, we cannot claim that pi was well known in the subcontinent in 3000 BC, but the people in Rig Veda ages knew the value of pi. Because there was a priest called Bodhayana 6th century BC claimed in his Sulva Sutras that perimeter of a circular pit is 3 times its diameter, which indicates the value of pi to be 3. But not only 3, the great Bodhayana used so many approximations of pi like 676 by 225, 900 by 289 and 1156 by 361. One more example, a little known part of Bible, Solomon's temple, it is mentioned that the King Solomon's worker Hiram made molten sea, which is 10 cubits from one brim to the other, means its diameter is 10 cubits and its height, that means depth, is 5 cubits and it compass about 30 cubits, means its circumference is 30 cubits. So if we consider only the face, that means circular in shape, circumference by the diameter is equals to 30 by 10 is equals to 3. Here one point to mention that Bible is written in Hebrew language and in Hebrew each alphabet carries some numerical value based on its position. In Bible, the word line in Solomon's temple is indicated by the alphabets Kuf Vav He, which has the numerical value as 111. But it is considered to be incorrect as in Hebrew language most of the words are spelled without vowels. So the pronunciation wise the alphabets are used Kuf and Vav, which gives the approximate value 106. If we find the ratio 111 by 106, it gives the approximate value of pi by 3. So note here, we cannot say that the Bible has said the wrong value of pi because the construction is so large, so high degree of geometrical precision is unnecessary. There are lot more examples from ages where we can find that people are behind the secrets of pi from long back. Pi in Babylonian ages. So this is a Babylonian tablet. So here you can see these are indicating something. So what they are indicating, let me show you. Observe here 2 I kept beside, and here the first one indicates, this one indicates 3 and this one indicates, look at here, 4 and 5. So let me consider 4, 5 and this one indicates 9. So these are assumption based. Let's go to the next slide. So this is indicating 3, 4, 5 and 9. So if we consider the positional context, so this is indicating the circumference. So let me consider 3 as circumference and 4, 5 as area, and let me explain in detail. Using positional context, we got 3 as circumference. So we can write 2 pi r is equals to 3, which gives r equal to 3 by 2 pi. So our area will be pi r square. In place of r, I am writing 3 by 2 pi whole square, which is giving me the result as 9 by 4 pi, because here 1 pi and here 1 pi will get cut. As we use number system with base 10 and Babylonians used base 60, but they don't have any place value. Like we use 45 means 40 plus 5, but no place value Babylonians used. Let us use 45 as contextual note, and it can be written as 45 by 60, 45 by 60 square. So many possibilities are there. Just we are assuming to reach at the value of pi. So I am using 45 by 60. So area 9 by 4 pi, what we calculated up here, this one 9 by 4 pi is equal to 45 by 60. So if we calculate, we will get pi is equals to 3. There is one more tablet found in 1936, but we don't have that image right now here. Just we are explaining what is written there. So this one I have shown here one picture where a circle inside a hexagon, that is hexagon is inscribing a circle. So it is written that perimeter of the hexagon divided by circumference of the circle is equals to the ratio 24/25. Now if I consider here a hexagon is inscribing circle, that means the radius of the circle is equals to the side of the hexagon, because we consider here the hexagon is regular. So we are getting here 6r by 2 pi r is equal to 24/25, which gives the result of pi is equals to 25/8. So here we got two possible values of pi in Babylonian times, Babylonian ages. Here what we have shown the calculations of pi, these are assumption based, and there are some articles also available in Google, you can search there. We have not verified the authentication. Now we are coming to pi in Egyptian age. The great Ahmes, who wrote the Rin Papyrus 1650 BC, presented volume of a cylindrical granary as V is equals to 8/9 d whole square h. D means diameter. So if I consider here this is cylinder, so this is presenting d, so its half will be radius. That means d is equals to 2 into radius. And here I have written, see, Ahmed said, cut off 1/9 of a diameter and construct a square upon the remainder. This has the same area as the circle. That means it is presented that a circle's area will be calculated by area of a square. But if radius of the circle is r, then side of the square will be, let me consider the side as a. So a will be equal to 2r minus 1/9 of 2r. Look at here, cut off 1/9 of a diameter. So 1/9 of a diameter and construct a square. Cut off, that means 2r minus 1/9 2r. So if I calculate this one, this is the side of the square. So area of this square will be equal to area of the circle. That means pi r square is presented as a square. If we calculate, we are getting a is equals to 8/9 into 2r. That's why v is equals to, we know the formula pi r square h. Here in place of pi r square, it is presented as 8/9 into 2r whole square h. So if we calculate here, we are getting the result as 256/81 r square h. So if I consider it as pi r square h, so pi is presented as 256/81, and hence the value of pi is presented as in Egyptian time 3.1605. Again, there are a lot more argument behind this. So we did research and we searched everywhere, and then we have presented it here for you. Later, to Greek mathematicians Antiphon and Bryson of Heraclea approached in an innovative way. Antiphon started with a polygon inscribing a circle and doubling its sides. Like, suppose we take a hexagon inside a circle, then doubling its sides means 12-sided polygon inscribing a circle, then 24-sided polygon inscribing a circle, and ultimately the area of the polygon will approach to the area of the circle. Bryson did the same, but instead of inscribing, he took circumscribing polygons of the circle. But finding the area of so many tiny triangles leads to rigorous calculation, which merely gave quite a few digits of pi. Now, where Antiphon and Bryson have left off, Archimedes of Syracuse took up the challenge and started at that point, but used a slightly different method. Archimedes focused on perimeter instead of area, and he considered inscribing polygon and circumscribing polygon both together simultaneously, and then doubling its sides. Like, if in a circle he considered hexagon inscribing and circumscribing, then in the next step he took 12 gun, next step he took 24 gun, and so on. And in this way he ended up with 96-sided polygon, giving the value of pi like 3 whole 10/71 to 3 whole 1/7. The value of pi lying between 223/71 to 22/7. In 263 AD, the mathematician Louis Hui independently solved for pi using the same approach Antiphon and Bryson did. He considered circumference of regular inscribed polygon up to 192 sides and found pi equal to 3.14159. Only 5 correct digits. At the end of 5th century, China mathematician father and son, father Su Chungchi and son Su Kungchi got only 7 digits of pi by considering inscribed polygon of a circle, but the polygon has 24,576 number of sides. Now here one important point. In 5th century CE, Indian mathematician Aryabhatta gave approaching value of pi, and he said that add 4 to 100, multiply by 8 and add 62,000, and by this rule the circumference of a circle of diameter 20,000 can be approached. Note here, Aryabhatta said approached, which gives the idea of irrationality of pi. And later in 1761, Swiss mathematician Lambert proved the irrationality of it. Here, one more contribution of Indian mathematician Brahmagupta is that he considered 12, 24, 48, 96 sides of a polygon inscribing a circle and said that the value of pi approached root 10, but which is quite wrong approximation proved later. Now, in the end of 16th century, François Viète, a French lawyer, used Archimedes' approach to 3,93,216 sides, and his final result was 3.1415926,535 less than pi less than 3.1415926,537. That means pi lies between these two values. In 1596, German mathematician Ludolf van Euler presented 20 decimals of pi by using same method of Archimedes by considering polygon of 5 million sides. Just imagine about the calculations. By the time of his death in 1610, he found 35 digits of pi. Do you know St. Peter's churchyard in Leiden commemorates Ludolf's contribution towards pi? Germans called this number pi as Ludolfian number still today to honor his extreme perseverance. Still now there was no symbol was assigned to represent this ratio. In 1737, the great mathematician Euler first used the Greek alphabet pi to represent this ratio, circumference and diameter. But wait, revolution of pi don't end here. More to approach yet. In 1672, James Gregory came up with a formula tan inverse x is equals to x minus x cube by 3 plus x to the power 5 by 5 minus x to the power 7 by 7 plus ... which is a very well known formula nowadays. Few years later, the great mathematician Leibniz said that as tan pi by 4 is equals to 1, so the formula what Gregory gave, we can replace x as tan pi by 4. So the formula gives tan inverse tan pi by 4 is equals to tan pi by 4 minus tan pi by 4 whole cube by 3 plus tan pi by 4 whole to the power 5 by 5 minus tan pi by 4 whole to the power 7 by 7 ... That means pi by 4 is equals to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus ... But using this formula, only 4 decimal places of pi can be calculated if we consider 10,000 terms of this series, which is indeed very hard to calculate by hand. Later in 1706, John Machine used tan inverse x plus tan inverse y is equals to tan inverse x plus y by 1 minus xy and found a formula pi by 4 is equals to 4 tan inverse 1 by 5 minus tan inverse 1 by 239. This formula is considered to be an improvement towards finding the formula to calculate pi, as tan inverse 1 by 239 converges after a few terms, and together with tan inverse 1 by 5 is also quite easy to compute. Using exactly the same formula, the mathematician and physicist William Shank calculated 707 digits of pi in 1873. But unfortunately in 1945, the mathematician Ferguson found out error in Shank's calculation after 528th digit of pi, and after 2 years of hard work, Ferguson gave 808 digits of pi. Then more 1.5 years later, Levi Smith and John Wrench calculated 1000 digits of it. Another breakthrough in 1949, ENIAC computer calculated 2037 digits of pi in just 72 hours. Now today, using computer algorithm, 62.8 trillion digits of pi have been calculated by Davis computer, just consuming 1700 watts of power, which is approximately same as our hair dryer. Now just imagine how computer replaced years of hard work of human to just quite a few hours of work. Now I am almost at the end of my video. Enjoy your learning, and just one more request to all of you. Hit the like button and subscribe my channel if you want more such knowledge to gain. So stay curious till the next one. Until then, tata.